Hello, my people. Um, so I figured out a way to record myself while I work on my iPad, and so it's going to show up on the screen. So, yeah, basically, I am a technological genius. But today, this is my first online lesson here, so if I'm super awkward, then that's why. But today we're going to talk about the pressure of gases. Pressure is the amount of force exerted on an object over a certain area. So, typically, an equation you'll see for pressure is pressure equals force over area. But we're not going to use that one that much. We are going to be talking about the pressure of gases. So for a gas, the pressure depends on two things. Um, the pressure depends on how often the gas molecules, or we'll say particles, because it's not always going to be a molecule, the gas particles collide with the wall and how hard they collide with the wall. So, for example, if I have like a tire, right? I should probably. If I have a tire, here's my tire, and in that tire are gas particles. Okay, and most tires have air in them. So let's say these are air particles. Um, what happens is, so you have uh, air particles on the outside too, exerting pressure on exerting a force on the outside of the walls, but you also have these air particles in the inside exerting a pressure, exerting a force on the inner walls of the tire, which allows the tire to stay in place, stay stiff. So the air pressure in here is a lot higher than the air pressure out here, so that when the tire presses down on, say, the ground, the tire can stay relatively in uh, formed, not deformed, right? Um, so the reason why the tire is able to do that is because it's got all these air particles colliding with the walls of the tire to um, to allow it to stay in place. Okay, so two things that affect the pressure is how many how many gas particles collide with the wall. Okay, so the pressure depends on, this is important, number of collisions with the walls of the container and Number two, it depends on the force that the gas particles collide, hit the walls with. Okay, so that's what the pressure of a gas in a container depends on. So now, how do we, if we want to talk about measuring pressure, how do we measure how do we measure pressure? So we typically have what's called a U-tube, okay? You're learning about U-tubes on YouTube. So, oh geez, I gotta do better than that. Sorry. Hold on. Give me a sec. Okay. So this is a U-tube. Okay. If I have the same pressure, typically in a U-tube, you'll have some sort of liquid. Okay. In a U-tube, you have a liquid. If the pressure is the same on this side and this side, the level of the liquid is going to be the same, right? So, but if let's say let's see if I get better at this. Shoop. Okay. Let's say I put a vacuum bulb on the top of this side over here. Now, if there's a vacuum over here, if there's a vacuum right here, then there's not going to be a lot of pressure being exerted from this side, right? So if you have, this is air on the other side, what's going to happen is the air pressure is going to push the level down here and push it up over here. Okay? And so the difference in these two levels is going to be how we measure the air pressure. Now, oftentimes this is mercury, this liquid, okay? And so this specific U-tube is called a manometer. All right. Now, you'll see that pressure is often measured in millimeters of mercury. Okay, Hg is mercury. Millimeters of mercury. So at sea level, the air pressure is 760 millimeters of mercury. Okay? And that's 1 atmosphere. Okay? So if we were at sea level here, this difference between these two levels would be 760 millimeters. Okay? So another unit of pressure that I want you to be familiar with is the kilopascal. Okay? the kilopascal, and that's 101.3 kPa is 760 millimeters of mercury, which is 1 atmosphere. Okay?